Hello everyone, so welcome to our work for our snow day for today. So keep in mind that this actually fell on a good day. Last Friday I showed you guys some notes. I only did a couple of examples, asked you to do one, and that was it. So today what I'm going to have you do is actually the practice. Now keep in mind that I did assign both of these assignments on Friday, but the notes took a little bit longer than I wanted to in class, so I kind of said, okay, just do the notes and we'll tackle the practice next week, and that's what we're doing today. I believe there was a couple students that finished this before I was able to delete it. I will send you an email saying, hey, you don't have to do this. If you just want to upload it just so that way you don't have a missing assignment and go to classroom, you can. But again, that's only to the people I'm going to email because there's only a few that finished before I deleted it, like at 8:40 or something like that. So your work for today technically doesn't have any notes. It's just the practice. So the first thing I want you to do is look at number 1, 2, and 3. Remind yourself, okay, a quadratic equation, what does the graph look like, etc., etc. I'm only going to do number 2 for you, so just get a head start. See if you could do number 2 on your own. So that way when I go over it, you're just kind of checking your understanding in this problem. And then your homework technically, or your practice can be 1 and 3 by yourself. We're going to go over those problems on Thursday, and then we're going to add to graphing a little bit more, or make them more specific, more accurate on Thursday. So we're going to add to what we know today. So let's build this foundation first before we start building on it on Friday. I believe I said Thursday, but I meant Friday. So try number 2 is the first one I'm starting with because there's a little watch out for statement that I want you guys to watch out for. Now, if you guys remember, anything that's in the form y equals ax squared plus bx plus c is what is considered a quadratic equation. Now, sometimes your x squared, your x, and your constant are not going to be lined up as perfect. So you can notice here in this example I'm trying to graph that everything is mixed up. Now, you could mix them back into order if you want, or you could just choose your a, your b, and your c just by looking for your specific term. Now, remember your a is always the coefficient of your x squared term, which in this situation is going to be a 1. Your b is always in front of the x term, which in this situation is going to be a -6, and your c is always going to be that constant, which is a -4. So keep in mind that that's what I did there. I tried to trick you guys, but all you have to do is just remember that, hey, it's not always the first term, second term, third term. That is my a, b, and c. It's whatever's in front of the x squared term, which is going to be your a, and so forth and so forth. Now, I know my b's look like 6. I wanted to let you know that that is b equals a 6. I'll try my best to make it more 6-ish. So let's start talking about graphing these. Now, just by knowing your a, b, and your c, you can find all this information, the y-intercept, the axis symmetry, the vertex, etc. You can pretty much draw a pretty accurate graph. Now, you know automatically, just prior knowledge, that whenever you graph something that's a quadratic, you're going to get something called a parabola. Parabola is just literally the shape of a quadratic. They're so important they gave them a special name. Now notice that it's either going to be facing up or down. Later on in the semester, you'll learn that they could actually go left or right, but today we're just worried about up and down. Now, it's really easy to know whether your quadratic is facing up or down. You just have to look for your a. If your a is positive, it's going up. If your a is negative, it's going down. Notice that our specific a is positive, so that means it's going to be going down. So this is what our graph is going to look like when we graph it. Now, let's go a little bit deeper in order to graph it. So there is a special property that happens with all quadratics. When you have a quadratic, you're always going to have something called an axis of symmetry. The axis of symmetry is what splits the quadratic in half and makes the graph symmetrical. That means the left side is going to match or be symmetrical to the right, and vice versa. So that axis of symmetry is what I always ask you guys to find first, and it's always the easiest. The hardest part about finding the axis of symmetry is remembering the formula. Remember, it is x equals a -b divided by 2 times whatever your a is. Just a reminder that whenever we are graphing vertical lines are always represented with x equals some constant. If it's whatever it needs to be, it's always going to be a vertical line. And that's what we're literally doing. We're finding that vertical line that splits my quadratic in half. And how do we do that? Well, just by taking the -b and dividing it by 2a. So let's go ahead and do that. X is equal to a negative whatever b is divided by 2 times a. Remember that your b, which we found earlier, is a -6, and your a in this situation is a +1. All we have to do now is the math to figure out what all this stuff equals. Negative times a negative is a +6. 2 times 1 is 2. And then 6 divided by 2 is just a 3. So we found our axis of symmetry. Let's draw this in our graph. So remember, this is a vertical line where x equals 3. This is my x-axis. I know that x equals 3 there. Now remember that it's a vertical line, so it's going to go straight through that point. And that is my axis of symmetry. Now you're pretty much there, because you'll notice that there is a very distinct connection, relationship between the axis of symmetry and your parabola, your quadratic, your graph. Notice that their intersection point is always the highest or the lowest point of that quadratic. We call that the vertex. In this specific situation, notice that this will be a minimum because it's the most minimum value, it's the lowest value it has. Now, the cool thing about that is that you pretty much have all the information. Keep in mind that where your quadratic and your axis of symmetry intersect is one and the same. That's what we call the vertex. That means that they're going to share the same x value. So if I'm finding the vertex, which is that point, the lowest point, I know my x value is whatever my axis of symmetry was, which is a 3. Now, in order to find its output, or the y to that single x, it comes a little bit more cumbersome because you have to use your formula. Your formula gives you, it's like the magic input-output machine, if you remember that from Algebra 1. Just by knowing this formula here, you know that when you input any x, you're going to get an output. That is what we're going to do. We're going to input our 3 to figure out what the output is of that specific vertex. So let's go ahead and plug that in. Y is going to be equal to -4 minus 6 times 3 plus 3 squared. Now I'm checking back, making sure everything's okay. Now I just got to do the math. I always like to start with my exponents first. So I end up with -4 times 6 times 3 plus 3 squared, which is a +9. Then I go on to multiplying. -6 times 3 is going to be a -18. Okay, now let's just do the math slowly. -4 minus 8 is a -22 plus 9, and I can see that -22 plus 9 is going to be a, let's see, 13, I believe. -13 to be exact. Let me double check. Yep, I believe that is correct. So that is my vertex. Notice that it falls off the page. Now we're only looking for sketch graphs, so don't get freaked out like, hey, my -13 would be somewhere down here. That's okay. Just put your vertex somewhere in the vicinity where it's supposed to be, and you're going to be okay. Now we are almost done now. So because we have our vertex, we have our axis of symmetry drawn, we know that our graph is going to be facing up, so it's going to look something like this. But I also want you to find the y-axis symmetry for now to help you make it more accurate. Now, the cool thing about the y-symmetry is that it's always going to be the point that crosses the y-axis. This is the y-axis. Your x is always going to be 0 just because no matter what, when you have an a y-intercept, your x is always going to be 0. Cool thing is that they're always going to cancel out. It's always going to be whatever your c is whatever your c is. Your c in this situation is a -4. So your y-intercept is actually pretty easy to find. Is 0, -4. 0, -4 would be located 1, 2, 3, 4 right there. Now remember that axis of symmetry is actually pretty nice because it'll help you be symmetrical to the right side. So notice that this is 3 units away from my axis of symmetry. It's going to be 3 units away on the other side. So that is my axis of symmetry, or sorry, that is my additional point. That's my y-intercept. I can draw it a little more accurately. And that is what I want you guys to be able to do today. Don't worry about additional points. We're going to add that on Thursday. If you could do all this work, you're going to be okay. Now notice what I did there. What I did here, I pretty much used 4 different colors, I believe. There's the red. That's the first step, is being able to locate your A, B, and C, so that way you know that you have a quadratic and whether it's facing up. Your next step is the green. The green is, hey, do you know the axis symmetry? Can you use your A, B, and C to find the axis symmetry? And then the next thing is your purple. Your purple is to use the axis or the x to your axis symmetry in order to find the vertex. And then, of course, the last piece is your purple, which is finding the y-intercept, which is the easiest because it's always going to be 0, whatever your C is. And then you have all your pieces of graph. So hopefully that example cleared things up. Hopefully you have 2 more to do. See if you got them, and then we could also go over these and just add to it on Friday.